Assalamu alaikum. Viewers, this video will help you in deriving the equation F is equal to ma. As you can see that I have already drawn some of the figures on this page. This figure has a smaller f, and over here there is a greater f. It means that this force is smaller and this force is larger. Both the masses are the same, and this force is producing a smaller acceleration and this force is producing a larger acceleration. As we know that according to the first part of the second law of motion by Newton, if acceleration is produced in an object, this acceleration depends directly on the amount of force applied on it. If there will be a smaller force, acceleration will be smaller. If there is a larger force, then acceleration will be larger. So acceleration produced in an object, keeping the mass constant, depends on the amount or magnitude of force applied on it. So this part of Newton's first law of motion can be expressed in this way, that acceleration depends directly on the amount of force applied on the object. So this can be taken as our first part equation of motion, of this motion. Now the second part figure is showing a different scenario. Over here we are noting that this mass is a smaller mass and this mass is larger mass, and the forces in both of them are constant or same. The acceleration produced over here is greater and the acceleration produced over here is smaller. According to second law of motion, keeping the forces constant, it is observed that acceleration produced in an object depends inversely on the mass of the object. If mass will be greater, there will be smaller acceleration. If mass will be smaller, then there will be a greater acceleration. So this part can be expressed in this way, that acceleration produced in an object depends inversely on mass of the object. This can be taken as second equation for this particular scenario. Now, if we combine the two equations, we can write in this way that acceleration depends directly on force and it depends inversely on mass of the object. This argument can lead us to this situation, that acceleration depends in this way, that F upon m. Acceleration is depending directly on force, acceleration is depending inversely on mass. Now we know that if we are going to note it as this part of the equation in such a manner that it has an equality in it, in that case we have to insert the sign of equality and a constant k for removing this symbol of proportionality. So A will become k into, A is equals to k into F upon m, right? Shifting m on the other side of the equation, we will get m into A upon, and we will shift this k over there, so m upon A, m into A upon k will be equals to F. In this case, the constant of proportionality is 1. So when you will replace constant of proportionality as 1, then you will get m into A upon 1. And since in denominator if 1 is coming, so there is no need to write it, so we can write m into A is equals to F, or simply we can say that F is equals to ma. And this is the same equation which we were trying to prove. So we can see that by the help of this particular argument, that I gave you, we can say that F is equals to ma can be shown by the help of Newton's second law of motion. Hope you have found this video helpful. Thank you. Jazakallah.